more substituted alkene. Important trick here, how to distinguish. See, it is the part where most of the students confuse. Simple line. Heat favors elimination reaction. So that no more confusion future. Observe this trick. Whenever high temperature given, elimination product is major. So E2, strong base and bulky base. What if I told you that just by looking at the reagent, substrate and solvent, you can predict the reaction under 10 seconds? Let's learn the trick. Hello students, let us start. SN1, SN2, E1, E2 reactions comparison. SN1, E1 reaction we are going to compare first. Reaction you see here, alkyl halide, that is secondary alkyl halide given here. SN1 with MEOH, polar protic solvent, E1 with same polar protic solvent as well as heat. When there is SN1 or you can say MEOH given without any heat, we consider it as SN1. Polar protic solvent along with heat given, along with heat condition given, then we consider it as E1 reaction. So simple trick here, whenever heat given that favors elimination reaction, low temperature, no heat given favors substitution reaction. So there is dedicated video for SN1, SN2, previous video. Once you look into it, SN1, SN2, purely for SN1, SN2 in detail, many examples we studied. So here it will give OH minus, nucleophile OH minus attack here and gives substitution product. But here in this case, E1 reaction, elimination, we eliminate X and followed by NE1 beta hydrogen, next adjacent carbon hydrogen, such that we should get more substituted alkene. More substituted alkene meaning more crowded alkene. We will see further what is more crowded alkene. So elimination reaction will give here alkene as major product, substitution above substitution reaction. If substitution product is found. How to distinguish E1, SN1 here? Heat condition favors elimination. See the mechanism here. Mechanism of SN1, E1 elimination. So here first step, halogen removed, that is halogen leaving group in slow step. Then carbocation is formed. Then after that, if it is following substitution reaction, if it is following SN1 reaction, the nucleophile O minus attack here carbocation and forms substitution product. If it is following E1 reaction, which is fast step, here also fast step, what happens in second step of E1 reaction? As it is in the presence of heat, adjacent to it, that is beta hydrogen or adjacent to carbocation hydrogen removed and alkene is formed. Intermediate carbocation in both the cases, alkene is formed, here substitution product is formed. How to distinguish? See, it is the part where most of the students confuse. Heat favors elimination reaction. Elimination, alkene is the product, substitution product. In place of halogen, you can write nucleophile. Okay. In substitution, Zaitsev alkene, we call it as more crowded alkene. More crowded alkene meaning the double bonded carbons with less number of hydrogens. Double bonded carbons with less number of hydrogens. Here no difference, it is symmetrical. Later we will see what is more crowded, what is less crowded alkene. See here. Here I gave comparison tables, no more confusion future questions. Any question easily you can solve with this comparison table. Very important. See here now. Number of steps in SN1 reaction 2, E1 reaction 2. Intermediate here also carbocation, E1 also carbocation. Yes, rearrangement possible. If any more stable carbocation possible, then you can rearrange. Here also rearrange. Reagent type, weak nucleophile, weak base. Reagent type, weak nucleophile, here weak base in both the cases. Reagents like H2O, ROH, aqueous AgNO3, aqueous Ag2O, NH3, NH2. Whenever these reagents given, think about SN1 reaction. These are polar protic solvents even, or you can say SN1 reagents. Here also same H2O, ROH, aqueous AgNO3, H2SO4 concentrated, H3PO4 concentrated plus heat. Along with these reagents, heat is given. Then you can easily distinguish SN1 from SN2. Rate of reaction directly proportional to alkyl halide. Here also directly proportional to alkyl halide. Solvent, polar protic solvent favors the reaction. Polar protic solvents favor the reaction. So what are polar protic solvents? Which are polar in nature and can produce protons. Polar protic, polar in nature and can produce protons. Protons meaning H+. ROH, H2O, RCOOH. Similarly, ROH, H2O, RCOOH. There is similarity, but products are different based on condition. Rate of reaction directly proportional to stability of carbocation. Here also stability of carbocation. Product is substituted product. Here it is alkene, you will get product in case of E1 reaction. Rate of reaction, tertiary greater than, secondary greater than primary alkyl halide, last it is less crowded alkyl halide. Even elimination also same, tertiary, secondary, primary and normal alkyl halide. Temperature, low temperature favors substitution reactions, high temperature favors which reaction? Elimination reactions. So here low temperature, high temperature favors elimination reactions. See, if you study like this with comparison table, no more confusion, future questions. Number of intermediates 1, here also intermediate 1, that is carbocation. Slow step is formation of carbocation, here also slow step is formation of carbocation. In fast step, attack of nucleophile occurs. In fast step, removal of beta hydrogen occurs in even elimination. That's what we studied in above mechanism. See what we did. In fast step, nucleophile attached here. If even reaction occurring under these conditions, so here beta hydrogen is next to carbocation removed. Okay. See here, both SN1, E1 occur simultaneously, but at low temperature SN1 major product, at high temperature E1 major product. So both the reactions occur simultaneously, but which decides major product, minor product? Low temperature favors SN1, high temperature favors E1. For example, see here. Here there is hydrolysis reaction which is commonly SN1 or E1 solvent reagent. H2O in both the cases I gave. H2O here, but where you can see difference? Along with H2O, heating given. Here no heating given. In such cases, first what we do? Breaking of the bond, carbocation form. Then from this OH minus attack, that is nucleophile. So SN1 here major product because low temperature gives SN1 product. How to identify SN1 product here? Substituted product. In place of bromine, just we are adding OH minus, or bromine is substituted by OH minus. SN1 product is major. Then what is here? Elimination product. After removing bromine, from any one carbon, adjacent carbon, hydrogen you can remove so that you will get alkene. For example, if I remove hydrogen from this, you will get here alkene. So E1 product is formed, SN1 product also formed simultaneously. But out of these two, major is SN1 because here low temperature favors substitution reaction. But same reaction along with heat given. Then what we need to check here? SN1 product form, E1 product form, but high temperature eliminates or favors elimination reaction. So in this case, alkene is major product, which is E1 is major product. So now you can observe this trick. Whenever high temperature given, elimination product is major. Whenever low temperature given, SN product is major product. Okay. Next, SN2 E2 reactions. So SN2 E2 reaction, first you see here reaction. So OH minus along with heating, OH minus along with heating. So here what we are doing, alpha carbon is connected to the halogen, beta carbon is next to alpha carbon. So what happens in E2 elimination? Here we remove hydrogen as well as halogen from adjacent carbons, hydrogen, halogen. So we will get alkene, which is E2 product. OH minus heating. Here just OH minus, no heating. In SN2 reaction, you can specify here also. Here already we specified it is SN1, it is E1 reaction favored. So here this particular reaction is E2 reaction, here it is SN2 reaction. SN2 reaction. So SN2 reaction OH minus attacking. So if it is SN2 reaction, already we studied in previous video, already mentioned in detail, dedicated with number of examples and tricks of SN1 SN2 we studied in previous video. If you did not watch previous video and come to this video. So now you see, here in this case, here halogen is on solid wedge. We know SN2 inversion of configuration occurs. So inversion of configuration meaning, if it is on solid wedge, it becomes dashed wedge. If it is on dashed wedge, it becomes solid wedge. Or if it is R configuration, it becomes S configuration. Based on chiral carbon, that is based on chiral carbons. But general representation you see here, if it is on solid wedge, we have to show on dashed wedge. Just inversion of configuration in case of SN2. Again, high temperature E2, low temperature SN2. So beta hydrogen as well as halogen should be anti-periplanar. Anti-periplanar meaning for E2 removal, especially for E2 reaction, that is two groups in same plane but opposite side. Like beta hydrogen, halogen should be in same plane but opposite side. Okay, here it is alpha carbon, if you see beta hydrogen, that is beta carbon hydrogen. Or you can show here it is beta carbon hydrogen, anti-periplanar according to E2. I gave here comparison table for easy understanding, observe it. Number of steps 1, here also 1. Intermediate, no intermediate, no intermediate. Rearrangement, no rearrangement, no rearrangement. Reagent types, strong nucleophile, here strong base, and bulky. Bulky favors E2 reaction. Okay, so here you observe it. You see here reagents, reagent type we mentioned, reagents. So here you specify reagents. For SN2, strong nucleophile, E2, strong base and bulky base, NaOH, RONA, NAI, KCN, AgCN, all these are reagents. All these are reagents for, okay, here it is strong nucleophile. So remaining all are reagents. AgCN, KNO2, AgNO2, NaNH2, RCOH, all are reagents for which one? Reagents for SN2. RONA, ETOH along with heating, tertiary butoxide, tertiary potassium butoxide, alcoholic KOH along with heating referred as E2 reaction reagents. Rate of reaction here, that is directly proportional to alkyl halide nucleophile, here are alkyl halide and base. Solvent polar aprotic favors. Rate of reaction inversely proportional to steric hindrance, but rate of elimination directly proportional to steric hindrance. Whenever more steric hindrance, more repulsion, then automatically it favors elimination. Product inversion of configuration observed, here alkene is formed. Rate of reaction directly proportional to stability of transition state, here also stability of transition state. Temperature low, temperature high, number of intermediate 0, here no intermediate in both the cases. Transition state 1, here it is 1. Rate of reaction primary, secondary, tertiary because inversely proportional to steric hindrance. So lighter alkyl halides react faster, secondary, tertiary, methyl halide. Here tertiary, secondary, primary, methyl halide. For E1, E2 sequence is same, E1, E2. See, in elimination, for smaller reagents and bases, the major product is Zaitsev alkene. For smaller reagents and bases, like less bulky base, Zaitsev alkene is more crowded alkene. For bulky reagents like this, tertiary butyl bromide or bulky base, tertiary butanol, like example I gave, the major product is Hoffmann alkene, which is less crowded alkene. See, what is more crowded, what is less crowded, how to find it? See here, the double bonded carbons with less number of hydrogens is more crowded alkene, which is Zaitsev alkene, which is more crowded alkene, or you can say more substituted alkene. Double bonded carbons with more number of hydrogens. That is less crowded alkene. Less crowded meaning that is less substituted alkene. Simply remember by identification, double bonded carbons with more number of hydrogens is less crowded. Double bonded carbon with less number of hydrogens is more crowded. When less crowded is formed, whenever bulky base like CH3CBr, tertiary butanol, like such reagents are used, then you will get less crowded Hoffmann alkene. For example, see here, alkyl halide aqueous NaOH, SN2 product major product, but under high temperature conditions, alcoholic KOH will give alkene as major product, which is E2 reaction here SN2 reaction. So now here Zaitsev alkene is major product. How it is formed? So here two possibilities. After removal of Br, either you can remove hydrogen from this side or this side. Any side you can remove. Hydrogen you can remove from left side or right side. But why we are removing from here? Because under Zaitsev alkene, more crowded is major product. So here more crowded meaning the double bonded carbons with less number of hydrogens. For example, if I remove hydrogen from here you will get more number of hydrogens. So more crowded is more stable according to Zaitsev alkene rule, where more crowded alkene is major product in E2 reaction. Whenever bulky base used, then less crowded you have to show. Less crowded meaning we have to remove hydrogen from this side, here you will get double bond. Key point, rate of SN1 proportional to stability of carbocation, rate of E1 carbocation, rate of SN2 inversely proportional to steric hindrance, rate of E1 directly proportional to steric hindrance. These key points more than sufficient to solve most of the questions based on SN1, E2, E1. See here, JEE Mains 2017 question here. Observe everyone question. See here, see the question here. So the major product obtained in the following reaction is, so here tertiary potassium butoxide given. It is tertiary potassium butoxide which is bulky base. Just now we studied which is bulky reagent or bulky base. Whenever bulky base is given, it favors elimination. At the same time heating also given. So it is plus isomer it is. That is a dextroisomer, I can say plus isomer. So directly you can think here, whenever bulky base is given along with heat energy, it gives less crowded alkene. Directly major product you will get in this case alkene. Here what they gave? Here they gave substituent product because TBU like nucleophile they added here substitution. Here also substitution. Here also substitution. So these are not possible. Only here directly less substituted, or you can say alkene is the major product. Directly you can ignore remaining options. Next. In this case, match the following given, observe it. So 1-bromo CH2 ethyl pentane, single enantiomer mentioned. So here what we need to check in this case, observe the reaction one by one. So here carbon is connected to CH2Br. Here carbon is connected to CH2Br, which is not chiral, which is primary carbon, which is not chiral. So whenever it is not connected to chiral CH2Br, if it is not connected, next carbon is whatever chiral carbon, C2 chiral carbon is, what is C2 here? 2-ethyl pentane, like here ethyl group, here hydrogen, other side. So it is chiral carbon. So 1, 2. So 2-ethyl, second carbon is chiral carbon, but first carbon is achiral carbon. To achiral carbon, bromine connected. To achiral carbon, bromine connected. So inversion of configuration here, achiral carbon, no inversion, but chiral carbon there should be inversion, but it is not attacking at chiral carbon. Bromine is here, so here nucleophile attack at this achiral carbon. So there is no change in configuration at chiral carbon because it is not attacking at chiral carbon. Bromine presented achiral carbon, which is non-chiral carbon. So there is no inversion of configuration at chiral carbon. Chiral carbon remains as it is. So for this you can consider retention of configuration. Where retention of configuration? Retention of configuration occurs at the chiral carbon. Why retention of configuration? Because chiral carbon there is no bromine. Bromine presented achiral carbon. So reaction occurs at achiral carbon, but chiral carbon remains unchanged. So here unchanged meaning that is retention of configuration. For P it should be 2. For P it should be 2. How many such options? Only 2 options. Answer should be among these 2 only. Next, minus means levorotatory. It is minus meaning 2-bromopentane. So 2-bromopentane here, if you see, it is like this. 2-bromopentane. I am showing here, see, for Q1, 2-bromopentane. So 5 here bromine. So it is chiral carbon because it 4 different groups presented carbon. So chiral carbon SN2 reaction, it should be inversion. It should be inversion. So here inversion you can see for this reaction. For this reaction, retention. So now overall combination if you see, only option B is correct answer, but we will see remaining also. Minus 3-bromo 3-methyl hexane. 3-bromo 3-methyl hexane. So 3-bromo 3-methyl hexane, which is a tertiary carbocation. It forms tertiary carbocation. We know tertiary SN1 reaction. Tertiary SN1 reaction, OH minus attack from both these sides equally. So whenever SN1 reaction here, so here racemic mixture is formed. Racemic mixture is formed. So mixture of enantiomers formed here, R3. And finally here aqueous NaOH SN1 reaction. So here SN1 reaction first here carbocation formed, then it shift to here. So then if we observe it, here mixture of diastereomers formed. Whenever compound having more than one stereo center, more than one stereo center means more than one chiral center, such compounds will result in diastereomers upon SN1 reaction. Okay. So SN1, SN2 reactions in detail already we discussed in previous video. Once watch it so that you will get more clarity. Here directly we discussed. So option B is correct answer. I hope all the questions clear to everyone. Follow these tricks so that within less time you can identify which is SN1, which is E1, E2, E1. Okay. Thank you. Thank you everyone.